Have you ever wondered how a tiny snail can carry such a big, heavy shell on its back? It's actually an amazing feat of biology and engineering, and it's not what you might think. When you see a snail, it looks like it's carrying a shell like a backpack. But when a snail moves, its shell moves with it. And if the snail dies, its shell stays with it. So how could this be possible? Let's take a closer look at this small but mighty creature and find out how a snail carries its shell. So we all know that snails have shells, right? But did you know that a snail's shell is actually a part of its body? That's right. Unlike hermit crabs, who have to search for empty shells to live in, a snail's shell is made while they are still in their eggs. But how does a baby snail make a shell without any previous experience or knowledge? Well, it all starts with their diet. When a snail hatches from its egg, it begins eating its own eggshell. You heard that right. Snails are cannibals. Well, at least with their own eggshells. Eggshells are rich in calcium, which is the main ingredient for building a shell. By eating their eggshells, baby snails get the calcium they need to start growing their new shell. This also helps them get rid of the egg, which is no longer needed once they hatch. After eating their eggshell, baby snails continue to eat other high-calcium foods like algae and plants to help their shell grow bigger and stronger. This is why you might see snails munching on leaves or other vegetation. They're not just looking for something to eat, they're also building their shell. Now that we know that a snail's shell is part of their body, let's take a closer look at how it's attached to the rest of their body. Inside a snail's shell, there is a soft tissue called mantle. The mantle surrounds the snail's body and lies just beneath the shell. The mantle is responsible for making the shell. It constantly secretes calcium carbonate and proteins that build up over time and cause the shell to thicken and expand in a spiral shape. As the snail grows, the mantle continues to secrete more calcium carbonate, which makes the shell grow larger as well. This is similar to how bones grow in our bodies. The mantle also makes the outer layer of the shell, which is called the periostracum. The periostracum is a thin, flexible layer that protects the rest of the shell from getting damaged. Now that we know how the shell is made, let's take a look at how it's attached to the snail's body. You might think that a snail's shell is attached to its body with a strong adhesive, but that's not the case. Instead, the shell is attached to the snail's body with special muscles called the columellar muscles. These muscles wrap around the inside of the shell and attach the shell to the snail's body. The columellar muscles are very strong, and they help keep the shell in place, even when the snail is moving around. These muscles are also responsible for helping the snail move. When the muscles contract, they pull the snail forward. This is how the snail moves at a pace of about 1 millimeter per minute. Yeah, I know snails are slow, but at least they have great grip. If you've ever seen a snail without its shell, you may have noticed that it has a kind of hole where the shell should be. This hole is actually where the snail's head comes out of. Snails can retract their head into their shell for protection or to conserve water, and when they do, they use their mantle to cover the opening of their shell. This keeps predators from getting in and also helps prevent water from evaporating. Another important thing about a snail's shell is that it grows with the snail. As the snail grows, the mantle continues to secrete calcium carbonate, which makes the shell grow larger as well. This is similar to how bones grow in our bodies. The shell is made up of several layers. The inner layer is called the nacre, or mother of pearl. This is the strongest layer of the shell, and it's what gives the shell its iridescent, shiny appearance. The middle layer of the shell is called the prismatic layer. This layer is made up of tiny rods of calcium carbonate that are arranged in different directions. This gives the shell its strength and allows it to withstand pressure from all sides. The outermost layer of the shell is called the periostracum. This is a thin, flexible layer that protects the rest of the shell from getting damaged. Snails need to absorb calcium from their environment to make their shells. They get most of their calcium from the soil, limestone, or food they eat. When a snail eats something containing calcium, the calcium is absorbed through the snail's gut and then transported to the mantle. The mantle uses the calcium to make the shell. If a snail doesn't get enough calcium, its shell will become thin and fragile, and may even start to dissolve. That's why it's important for snails to live in areas where they can get enough calcium. In captivity, it can be harder for snails to get enough calcium. So it's important to give them a diet that is rich in calcium and to make sure they have access to a cuttlebone or other source of calcium. Snails can also get calcium from the soil where they live. This is why it's important to give captive snails a substrate that is rich in calcium. Snails don't just need calcium to make their shells, though. They also need it for other things like muscle function and nerve conduction. Calcium is an important mineral that plays a role in many different bodily functions. Let's take a look at what happens when a snail doesn't get enough calcium. When a snail doesn't get enough calcium, its shell can become thin and fragile and may even start to dissolve. This can make it difficult for the snail to move around and can make it more vulnerable to predators. In severe cases, a lack of calcium can even cause the snail to die. That's why it's important for snails to get enough calcium in their diet and to make sure they have access to a cuttlebone or other source of calcium. Snails can also get calcium from the soil where they live. That's why it's important to give captive snails a substrate that is rich in calcium. In addition to calcium, snails also need a variety of other nutrients to stay healthy and strong. These nutrients include protein, carbohydrates, fats, vitamins, and minerals. Snails can get these nutrients from the food they eat, such as plants, algae, and even other animals. It's important for snails to have a balanced diet in order to stay healthy and strong. The next time you see a snail, take a moment to appreciate the amazing feat of biology and engineering that is happening right in front of your eyes. From the way its shell is attached to its body to the way it grows and develops as the snail grows, there is much to marvel at. So what did we learn today? We learned that a snail's shell is actually a part of its body and not just a backpack it carries around. We also learned how the shell is attached to the snail's body with special muscles and how it grows as the snail grows. Finally, we learned that snails need to get enough calcium from their diet in order to have strong, healthy shells. If you enjoyed learning about snails today, and if you have a favorite snail fact that you want to share with others, feel free to leave it in the comments below. Who knows, you might teach someone something new. Thank you for watching, and I hope to see you again soon. Bye.